Okay, welcome everybody. This is lecture 21. This is about piecewise defined functions. This is chapter 2, section 4. So a lot of this stuff is going to be somewhat familiar to you, I hope. And we're just going to be kind of talking about it in a new context. So dealing with a piecewise function. So really, I'm just going to do one problem in this lecture. But we're going to ask 5 different questions about this particular function. So this function looks like this. Oops. Equals, and this is a function with 3 pieces. This is 2x plus 3, 16, and negative 1 over 2 x plus 1. And it's going to be this if x is less than negative 2. It's going to be 16 if x is equal to negative 2. And it's going to be negative 1/2 x plus 1 if x is greater than negative 2, but less than positive 2. Okay. So the first question is going to be about the domain. What's the domain of this function? So the domain is all the possible x values. So we want to really focus on just this part of the function, of the expression. X can be less than negative 2, it can be equal to negative 2, or it can be between negative 2 and positive 2. But it seems that we have no part of this function where x is beyond positive 2. So if we looked at this on a number line, right? Here's 0, here's negative 2. So part of this function is going to be for numbers smaller than negative 2. Part of this function is going to be for numbers at negative 2. And then part of it is going to be for numbers that are larger than negative 2 and going up to 2, not including 2, but up to 2. Okay. And that seems to be it in terms of the information that we're given. So our domain, again, in interval notation, we are going to go from negative infinity up to positive 2. Negative infinity is not included because it's never included. And this is less than or greater than, and not less than or equal to or greater than or equal to. So this is also going to be a soft parentheses there. So that's our domain. Okay, so that was pretty easy. Next, I want to find our intercepts. So we have potentially 2 intercepts. We have a y-intercept and an x-intercept. Our y-intercept is going to be when x is equal to 0, and our x-intercept is going to be when y is equal to 0. Okay, so it's easy enough to find the y-intercept. So when we're looking at the y-intercept, our x is equal to 0, so the part of this function that would be relevant is going to be this part, right? If x is equal to 0, then it is between negative 2 and positive 2. There's the 0. So we want to look at that last piece of the function. So just looking at this, if we put 0 in for x, we should get 1 for y. So our y-intercept is x equals 0, y equals 1. I realize I wrote that in a really confusing way. I should have written xy like this. X is 0, y is 1. And then next we're going to find if y is 0, what x is. But this way, the intercept is 0, 1, comma, and then after the comma, that's where we're going to put the y-intercept. Okay, so now in terms of the y-intercept, what can we do here? Well, we don't know what x is, right? We only know that y is equal to 0. So we've got to take this kind of one step at a time. So first, let's look at this function here, this 2x plus 3. What value of x would cause that to be equal to 0? So if I said 2x plus 3 is equal to 0, that would be 2x is equal to negative 3, and I would divide both sides by 2, and I would get x is equal to negative 3 over 2, which is the same as negative 1.5. It's 1.5. Okay, so now the question is, if that was my x value, would I put it into this expression? And the answer is no, I would not, because negative 1.5 is greater than negative 2. And this is only for values of x that are less than negative 2. So that one doesn't work. So we just have to abandon it. Now let's take a look at the next one. This one is 16. 16 is never going to be equal to 0. So kind of don't have to worry about that one either. Now let's take a look at this one. So in this case, I want to set that expression equal to 0 and find my x. So that's going to look like this. We've got negative 1/2 x plus 1 equals 0. Subtract 1 from both sides, and that cancels. And we have negative 1/2 x equals negative 1. If we multiply both sides by a negative, that becomes positive, and this becomes positive. And then we get x equals 2. Oh, x equals 2. Okay. So would that be potentially a y-intercept? Well, so close, so close. It would not be actually, because if I had x equals 2, this part of the expression would not quite include that 2. Okay, I can tweak this just a little bit to make it work out nicely where I have a y-intercept. And that's what I'm going to do right now. All I'm going to do is I'm going to change this 2 into a 3. If that were my problem, then this in the domain, that 2 would also become a 3, right? Because I'm going all the way up to 3. And now this would be exactly, this would work out really well. If x equals 2, then I put it into this expression, not any of the other expressions, because this one is only good for negative 2, and this one is only good for smaller than negative 2. So if I had x equals negative 2, I would only put it in this expression, would only put it here, and I would get 0, in fact. So if x equals 2, y equals 0. So my intercepts are 0, 1, and comma, and in parentheses, 2, 0. Okay? Those are my intercepts. Now I want to graph this thing. Okay, so let's graph this. Let's see what this graph looks like. So I'm going to draw an x and y axis. So there's my x-axis. There's my y-axis. I'm going to go ahead and put in the intercepts. So I have x equals 0, y equals 1, and also x equals 2, y equals 0, like that. I'm going to graph this top part of the equation first. So 2x plus 3. That gives me a y-intercept of 1, 2, 3, and a slope of 2. So that would be up 2 over 1. Up 2 over 1, up 2 over 1. I can also go down to back 1. Back 1. Now, I only want to do, well, I'm just going to go ahead and connect it with a line. I'm going to make a dotted line. Okay, that's the top part of my expression. Then I have this piece here. if x equals -2, y equals 16. So that is going to be, here's my -2, here's -2, and y equals 16. So let me see if I gave myself enough space here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I've got a point right there. Okay? And then finally, the last piece of my expression, last piece of my piecewise function, is this one, -1/2 x plus 1. So for that, and I'm just going to change my color here too. Plus 1, and the slope is -1/2. So that is -1 over 2, -1 over 2, -1 over 2, like that. Okay. And then I can also go back to up 1, back to up 1. Okay. Now, here's the interesting thing. My first function is valid only for values of x that are less than -2. So that means all of this part of the function where x is greater than -2, that's not on this blue line. And then finally, right here, I want to have a dot, but my dot actually has a hole in it because the value of the function is not really there. That point is really way up here, right there. Okay. Now, my orange function is the last one that I graphed. That one is only true for -2 up to 3, and then it ends. So I can follow this one from -2. That's okay. -2 up to 3, so 1, 2, 3, up to around there, and then it ends. So I'm going to erase everything else, and just going to make sure that this looks like it's a hollow point, and this one is hollow too. And it's hollow there because of this less than sign. It's not less than or equal to. Okay, so there it is. That's my function. All right, I've got that little blue piece and that little straight orange piece, and then I've got this point way above it. So now that I've graphed it, now the next thing I want to do is find the range of my function. So this is going to be a little bit tricky. And I can tell you right now, the mistake that you're likely to make is that I think you're likely to say that the range of this function is from -∞ up to 16, like that. And 16 gets a square bracket because the function actually is there at 16. Okay, the problem with that is that even though it does go to -∞, right, this function keeps on going in this direction. So -∞, that part is correct. The problem is that it goes up to, it has values basically everywhere. I should have made this a little bit steeper, and then it would come, because technically there's just like a little phi gap in between here and here. Yeah, I guess I should kind of worry about that a little bit. So I think I accidentally made a problem that's a little bit harder than what you're going to have on the homework, but that's okay. So the range for this part of the function is from -∞, and it goes up to -1. You see that? So this is where that blue part tops out at -1. And it's going to be soft brackets around both of those. Now, right here between -1 and this is like -1/2, right? So if I went to y equals negative, oh, I don't know, 0.6, I would not have any of my function there because it's in the gap between this blue piece and this orange piece. So technically, my range picks up again. So it's got that orange piece picks up again at -1/2, and it goes all the way up to 2. And it's an open interval on both ends. Okay, and then finally, here's my point way up here at 16, just all by itself at 16. So then I've got this 16, and that point really is there. So I'm going to give it square brackets. And then my range is what's called the union of all of these sets. And that union symbol is just a U without its little cane, just a sort of freestanding U like that. And that's one of the buttons that appears on the bottom of your screen when you're doing your homework. U. So there we go. That's the range. And then one of your questions on the homework asks, is the function continuous? So the question is this continuous? Let me spell this correctly. Continuous. Okay. This one is not continuous because there are gaps in the function. So a continuous function is where every point is next to every other point. So this one is discontinuous. It's discontinuous in 2 places. Well, actually, in 2 places. It's discontinuous here, right? Those 2 points don't match up, or like these 2 points don't match up, and then this point doesn't match up with either of these. Okay. So let me go now to the graph, and I'll give you an example of a function, of a piecewise function that is continuous, just so you can see how that's different. And I'll make it a function with a parabola on it too. So that'll be kind of fun. Okay, let's try that. And I think we can go over to here. All right, so we're gonna have a function, x, and I can say equals. So I'm gonna use that curly bracket, and then I need the condition first. So x is less than -2, and then I use a colon, and then I use the function. So 2x plus 3, and then comma, and then again the condition. So x equals -2. The function, colon, the function, which is 16, and then comma, and then finally my last condition, which is from -2 is greater than -2, but less than, and we changed it to 3, didn't we? We changed it to 3. So that's my condition, and my function was -1, oops, -1, -1/2 x plus 1. Okay. And that's my function. Oh, well, oh, nice try, Desmos, but didn't quite do it for me. Because if you notice, it tries to connect all those parts of the function together. Oh, actually, wait, maybe that was my fault. Maybe did I do this? No, x is greater than -2. I didn't do greater than or equal to, so I don't know why it connected those. It should not have. Take that out. And I'm just going to put in a point. So that point is -2, comma 16. And I'm going to label it. And I'm actually going to change it to this red color. Okay, there we go. So now there's my function. So you can see I've got this bottom piece. That was the part that I had in blue on the previous screen. And then I've got this other piece, and then I've got this dot way above it. Okay. So if I wanted this function to be continuous, what I would have to do is I'd have to make all those pieces join up together. So this piece, this -2, 16, what if I change that to -2, 2? See how now it's joined up with that previous piece? And then this piece, this 2x plus 3, what if I make that 2x, I think, plus 6? Ah, okay. So now this piecewise function is continuous. Every point lines up with every other point, even though it's defined differently, and even though it has that corner on it right there. So it's not a smooth function, but it is continuous. It's a continuous function. All right. Well, that was piecewise functions, guys. And that's about all I've got for you. So thanks for tuning in, and we'll see you next week. Thanks. Bye-bye.